Okay, this video is going to be focused on an illustration of missing data. And I'd like to just review a few things that we deal with when we look at missing data and do an analysis of it. We want to consider variables that have a lot of missing data. We want to examine those and consider what we want to do with a variable that may have a lot of missing data in it. We also want to look at individual observations that may have a lot of missing data among them. So if an individual respondent, for instance, failed to complete the entire survey, we want to identify the extent to which the survey is not completed and whether that's a problem or not by observation. If the survey has a specific variable that is missing a lot of data, we also want to dig into that variable and consider why it may be missing a lot of data too, and then decide what to do with it. So that's what we want to begin with. We want to think about variables and observations and the percentage of missing data for each. We also want to note and think about strongly why data may be missing. So if we notice that a particular variable is missing a lot of data, we want to ask ourselves, well, why would that variable, for instance, be missing data and other variables not be missing data? That's a consideration that we certainly want to take into account. Or we want to think about a specific observation that may be missing a lot of data and again ask why by observation that data may exist. If we can explain why the data is missing, then that lends us a lot of support as to what we want to do with the data, whether we want to delete an observation or delete a variable, or if we want to replace those missing data points with something else. So being able to explain why the data is missing to begin with is very helpful. So that's something we want to think about. We also want to think about what a cutoff measure might be for too much missing data. So oftentimes we use a 10% type of a benchmark by observation. So if a respondent completes a survey but they miss or fail to complete it by 10% or more, we may consider dropping that observation. Or if a variable has anywhere from 5 to 15% of its data missing, we may consider dropping that variable. In either case, something to remember is to remember where the data is missing. So in other words, if the data is missing on variables that are not likely to be very important in our research, then even though they're missing, it may not be relevant. So another way to think about this is if you have a very, very important variable and you have a missing data for that specific important variable, that's more problematic than if you have missing data on a variable that's less important to your research. So keep that in context. That's the practical approach or practical way to think about how we're going to look at this. So how much data is too much data? That's number 4. Number 5, we want to think about whether the data that exists is from respondents that are fundamentally different to those whose data is missing. So in other words, if there's missing data, is it because there's something different about the respondents, or is it just random? We want to be able to understand that significance there at that level. And then finally, we want to decide what we're going to do about it. We could do nothing. We could just leave the missing data as it is, or we could decide to delete observations or variables, or we could decide to replace missing data with some other proxy or some other simulated data. That would be an option too. So to look at this, we're going to think about a data set, and this is data set that we have here. It's called HBAT missing, HBAT missing. So this data is available to you, and you can pull this up and you can look at this yourself. You'll notice in the data set we have observations. There are going to be 70 observations. So this is a subset of the HBAT database or data set, and it's going to have variables 1 through 14. Some of these variables are metric and some of them are non-metric. So we see a missing space here for 202, another one in variable 3 for 202. We see variables missing data for observation 210, a lot of missing data for them, like 7 or 8 different data points are missing. So that's maybe problematic. We may consider dropping 10. As we go down here, it's hard to discern whether there's a particular variable that's missing more than others. It seems like these variables 1, 2, 3, seems like there's a lot of missing data there. So we need to see what's going on. So what we're going to do is go to Analyze. We're going to go to Descriptive Statistics, and then we're going to go to Explore. I've already dropped in here our metric data. And so we can look at our metric data. One of the things we want to do is, I don't need plots here. We really just need the statistics. And when we look at the statistics, we've got descriptives that'll be given, which is fine. It's no problem. The other thing that we want to do, though, in this case, specifically, is we want to exclude cases pairwise. Because we really want to know, variable by variable, how many are being provided, how much data is being provided for each one. Okay, so this is a variable analysis then. I'm going to click OK here. We'll have our descriptive statistics down below by variable. So we have means and standard deviations and all that good stuff. But then here in the cross-processing summary box, what we have here is the number of respondents and the number of missing data that's there. So we have cases that are missing and then valid cases. So we have 21 missing data points for variable 1. That's 30% of the data. We have 24% of the data missing for variable 3 and 18% missing for variable 2, and then it kind of goes down. We have 12, 13%, and 10% for some of these others, and so on. So these other ones, variable 4 through 9, would probably be okay, generally speaking, in terms of a total volume of missing data. These first 3, though, may be problematic, and certainly if you're missing 30% of your data, if variable 1 is an important variable for your research, this is a problem. Okay, so this is problematic. There's a reason why this variable is not being answered, and so we need to figure out why. And we may go back to the survey and see if the question was worded awkwardly or something along those lines. And this is a little side note. When you construct a survey, the first few questions that you ask should be warm-up questions to get the respondent familiar with the instrument and get them used to answering questions. If you begin a survey with a very important question to your research, then you may run into this problem. So these may be like, the respondents may be just warming up and they might not be real responsive yet. So that might be it might be an instrument problem that's being developed. So let's just remember variable 1, 2, and 3 may be problematic, and we want to look at those a little bit in a little bit more detail. So we know those are those. Let's look at analyze. Let's look at frequencies, and let's put in our non-metric data over there, and we can use, frequency tables would be the norm for that. Let's just do OK and see what happens. We look at the statistics here, we look at the valid and the missing, and here for 10 through 14 we're only missing 2, 1, 2. So we're really only missing about 8 or 9% of our data for these non-metric data points. That's not bad at all. That's good. That's a very small percentage compared to the other data. So variables 10 through 14 appear to be fine in terms of what's missing or what's not. So if we're looking at a variable issue, then we're looking really at 1, 2, and 3, and we want to look at those more carefully. So, all right, so that's part of the analysis. We also want to look at observations, at each observation, and like we want to be able to determine whether there's missing data and whether there's a lot of missing data, observation by observation. That's going to take a little bit more of a process. We're going to go through a couple more steps here to identify and to understand exactly what we need to do for those. So we're going to create a new variable, and this new variable is going to be plopped in here, and it's going to describe count actually how many variables are missing or how much data is missing. So we'll go to transform, right? And then we're going to go to compute a variable. And what we're going to do is we're going to name this thing missing data. Now, you can name it whatever you want, but missing data is what we're going to do. And then we're going to come over to the functional group, and we're going to come down to missing values. And what we're going to do is we're going to call the function nmiss. nmiss. Okay, so this is what we're going to plop in there. I'm going to double click nmiss, and what we want to do in here is we want to put our variables, and we'll separate our variables by a comma. So v1, and I'm going to just double click on each one of these with a comma separating each one. And what we're doing is we're creating a new variable that's simply going to count when a data point is missing for each observation. So let me finish that. So we have variables 1, 2, 3, 4, 5, 6, 7, all the way up to 14. Okay, that seems to be good. That seems to be about what we want to do. I'm going to do OK here. And the output down here says we computed a new variable. That's good. Let's look at that variable. And we have a new variable in our data set. It's called missing data. So respondent 201 here has no missing data. Respondent 202 has 2. We have a 7 there. We have another 7. And we go like that. Okay, so now that we have this data point here, we could actually take this data point and we can look at it as a frequency. So we can go analyze frequencies. Now we have this new data point here called missing data. So we're going to look at this new missing data point. I'm going to look at its frequency. We have a score for everybody. 26 or 37% of our respondents completed the survey in total. 8.6% have 7 missing data points. 5.7 have 3, and so on. So now what I could do is I could choose to eliminate these 6. Or I could choose to eliminate observations that have a lot of missing data. Again, when you're missing 7 out of 14, that's 50% of your data that you're missing. All right, so that may be problematic. That may be something that we want to address further. So at this point, we have the option of eliminating variables 1, 2, and 3. If those variables are not significant to our research, and we have the option of eliminating maybe 6 or maybe even 10 of our respondents, given the number of variables that they didn't answer, the amount of missing data. So maybe we drop 10. Maybe we drop this number, or we drop 214. Maybe we drop this one down here, 233. That's something to consider. Now, it may be that these are just random, that there's nothing significant, in other words, about 210, 214, 233, these respondents in particular. Or it might be that they have something about them that's causing them to miss data in a systematic way. So that's another thing to think about. So what we're going to do is we're going to look at whether there's randomness in this data or not. So what we can look at is computing a new variable. So again, we're going to compute a new variable. So we're going to transform, and we're going to recode into different variables. I'm going to recode into different variables. Now, this you need to do one variable probably at a time. I'm going to do variable 1 because that was my most problematic variable, and I'm going to look at variable 1, and we're going to rename this and create this. I'm going to call it V1, and I'm going to do maybe an underscore missing. I'm going to change it to that. So this is going to actually create a new variable for us, and I'm going to do change, and then I'm going to do old, and I'm going to do new. Now, so I did old and new, and I'm going to put system or user missing here. System or using missing. I'm going to put a 0 in here. So basically what's going to happen is if there's a missing value for variable 1, it's going to give us a 0. And then if there's something other than a missing data point in there, oh, I've got to add that. Sorry, got to add that. And if there's something else in there, all other variables, I'm going to, oops, actually, I'll remove that. System do 0. I'm going to add that in there. If it's missing, it's going to be a 0. If it's an all other, if it's something other than missing, it's going to be a 1. Okay? So all I'm doing is creating a new variable, and it's going to tell us, it's like a dummy variable that's basically going to tell us whether there's a missing data in variable 1 or not. I'm going to do OK there, and I'm going to do OK again. Okay, we created this new variable here, and it's going to be V1 missing. All right, so now we know whether we have this new variable, and we know whether there's a missing variable there or not. We know that there is a data point for V1 for our first respondent, so we have a 1 there. We know it's missing for 202, and so we have a 0. Okay, so that seems to be right the way it is. Okay, so now we can do a little bit of testing to see whether there's randomness going on or not. So to do that, we're going to go to Analyze, Compare Means, Independent Sample T-Test. All right, so what we want to be able to do, we want to use this new missing data as a grouping variable. And then what we can also do is look at whether the missing data is significantly different by respondent group, if you will, to our other variables. So we have our other variables. We'll plop in there. We have our new variable, so we have our missing data as group 1, and we have our non-missing group data as group 2. We'll continue. And so what we're going to do is basically a between group test for people who answered this in V1 and people who didn't, and see if those who didn't respond behaved differently on the rest of the questions than those who did. Right? So we'll do OK, and we have the results then. And what we want to look for are issues that deal with significance here. So we have 2 through 9, and between the two groups, is there a significant difference in how the group that responded and the group that didn't respond, did they behave differently on variable 2, 3, 4, 5, 6, 7, 8, and 9? So on 2 they did not. On 3, they did not. On 4, there was a significant difference between how our responders answered and how our non-responders answered. Okay, V5, also another similar problem. Our responders and non-responders behave differently. V6, no difference. V7, no difference. V8 and V9, there is difference, although V8 is marginal. Okay, so anything below 0.05 is going to be something to look at. So V9, V5, and V4. V8 is marginal. It's significant at the 0.10 level, which is not too significant with a sample size of 70, but still, it's concerning. So, what we can say is that the people who answered V1 behave differently than the people who did not answer V1, and they behave differently on questions 4, 5, 8, and 9. So this gives us even more pause for concern. We really think that there's something going on with this V1. It gives us more support to drop that variable and move forward. So I would consider dropping this variable, and we would consider doing the same test for variables 2 and 3 because there's a lot of missing data for those specific data points. So that's where we are. Now, the question is, should we do something with V1? Should we try to replace these missing data points? If we choose to keep V1, we could do that. Now, we may want to drop V1 altogether, or we may want to try to replace these data points. So now another thing, so to replace data, then in a data set like this with SPSS, we're going to again create yet another variable. This new variable will basically be the replacement for V1. Okay, so we go to transform, we go to replace missing values. We want to use V1 as our value, and we want to decide here how we're going to replace it. Okay, remember we could use a replacement by mean. We could use a hot deck, cold deck replacement strategy. We could do some type of regression type of replacement as well. Again, this is an imputation method that we're choosing. And so we want to decide, okay, I've got a missing point. What would I put in that missing point if I was going to replace it with something so that I had data there? So we have a new variable that's going to be created, and then we have a method here on which we can decide how we're going to replace that particular mean. Or not mean, but how we're going to replace the actual data point. So we can you take the mean of the series and place that in. That's probably the easiest and simplest to do. The mean by nearby and median by nearby points is kind of like a hot deck, cold deck type of an approach. And then these linear approaches are more like a regression type of an approach. Okay, so that's kind of how you think of these in SPSS. If we did just a series mean replacement, again, that's probably the simplest. We're going to do okay. And then again, in our results here, it kind of says that we did that. And when we go into the V1 variable, this is the new variable that would replace V1, then you see here that we have the existing data from those who responded already. So 3.3, 3.3, it's there. But then for these missing data points, what it's done is it's dropped in a 4.01, which is the mean of this column. It's the mean of this column. So now we have a new variable, we have the old variable. The new variable has our imputation provided us. We used a mean replacement in this case instead of a hot deck, cold deck approach or a regression, which you could have done to calculate what should go in there for those. The last step and the last thing that we can do is we can compare the new variable to the old variable. And what we want to do is make sure that the new variable is not significantly different from the old variable. Statistically speaking, that the characteristics of the variable remain the same. However, we have a full set of data. So we can go to Analyze, and this time we're going to do a paired t-test because we're pairing, we're using two data points and we're comparing them within each subject. So we'll use V1 as a variable and our original V1, and then we're going to use our new V1 as our comparative variable. We're going to do this, and what's actually interesting, and this happens, is that we look at these sample statistics. They're almost identical. Okay, so there's almost identical. So they can't even create. So SPSS is even having difficulty creating a test here because they're almost identical variables. So that's actually a good sign. That's actually positive. It means that what we created that's new duplicates the characteristics of the old V1. However, now we have data where there was missing data before. Okay, so this is just a summary, kind of a practical walkthrough on analyzing a data set for missing data and then doing something with the data once we notice that there's a problem or an issue that has occurred.